In this recording, we're going to talk about inverses. And before we get too formal in terms of what an inverse is, let's just have you look at some examples here and just kind of do a little discovery. Okay, so you're familiar with the notation f of x. So I'm going to do f of New York equals Albany. Okay. Inverse of f, that's what this notation is. Kind of looks like a -1 as an exponent, but it's not an exponent. It's just notation for inverse. The way we read it is inverse of f of Albany equals New York. So I think you can kind of figure out what's going on with this particular function. So if I say f of Connecticut, I get Hartford. Inverse of f of Lansing equals Michigan. Okay, so I think you can see what's going on here. It has to do with some state capitals. So if you can figure out what goes in each of these blanks, okay, noting that sometimes it's f of a particular input, sometimes it's inverse of f of that input. Okay, I'd like you to fill in those blanks, and then there are 4 opportunities for you to fill in your own examples. If you need to go online and do a little Googling, you can do that. Okay, so pause and fill in all these, and then play the recording when you're ready. Okay, so hopefully you got some examples. The first 4 are going to have to be what they are. You got to have Wisconsin, Phoenix, Honolulu, and Colorado. The last 4 are wide open, so you may have come up with other examples, just so long as you're always taking f of a state and returning its capital. Inverse of f of a capital returns its state. So that's a notion of an inverse. Okay, if I do f of New York, I get Albany. F of Albany, it gets me back to where I started. And inverses are just operations, often things like take off your shoe, put on your shoe. Okay, things like that have an inverse. And not all functions do have an inverse that are functions. Okay, and that's what we're going to look at soon. Our next example involves Celsius and Fahrenheit. Okay, so I'd like you to do some reading here, read through this section, and then play the recording when you're ready. Okay, so I don't know how much experience you've had dealing with Celsius. For me, it's a sort of a different mindset. I'm not as comfortable if someone says 25 degrees Celsius, really knowing what that feels like. I do know, obviously, the boiling point and freezing point. I'm familiar with those. But in terms of the other ones that don't have a real feel for Celsius. So I always want to turn it back into Fahrenheit to get a feel for it. So we're going to try to make a function here, a correspondence between those 2 units of temperature. So let's take those 2 points. If you haven't plotted them yet, plot them. We've got that Celsius has a certain boiling point and freezing point, same with Fahrenheit. Plot both those points according to what this says, and then play the recording when you're ready. All right, so hopefully you came up with plot of those 2 points and then drew a line through them. Extend it a bit into the negative direction. Certainly we can have negative temperatures, as we know in central New York, but the meaning of why we're extending it is going to be apparent later as well. Next, we're going to come up with an equation for this line. And a line has both a slope and a y-intercept, or a rate of change and a starting point, if you like. And so why don't you do what you can do to come up with the rate of change? What's the slope of that line? And then we'll play the recording and work out what that equation is. Okay, so one way of thinking about slope is a rate of change. So what is the change in y, which is 180, divided by what is the change in x? So I've got 180 divided by 100, which we can simplify. They're both divisible by 20 to 9/5. So that's our rate of change right here. I can write it as delta y, which is change in y, if you haven't seen that notation, over delta x. That's going to try to be an x. All right. All right, so that's our change in y over change in x. And then when we write our equation, we're going to need the starting point. So we're starting out when x is 0 with a y value of 32. We can see that on the graph. So we've got something like this. Y equals 9/5 times x plus our starting point of 32. All right, so that's our equation. And we're going to call this one f of x. All right. Let's proceed. Now it wants to know what is the temperature in Paris in Fahrenheit if you know the temperature in Celsius is 25 degrees. So go ahead and work that out. Play the recording when you're ready. Okay, so hopefully you took time to figure that out. This is an x value into our function, right? Because you think back to the graph has an x-axis that represents Celsius, right? That was the x in our function. So when we go to our function, we work that out by subbing in 25 for x. Now you just need to do this math, do the operation. So divide 25 by 5, multiply that by 9, add 32. You're going to get 77 degrees. So actually it's kind of an optimal temperature, 25 degrees Celsius. It's a nice temperature to be out, right? All right, so let's do a little bit more with that. Let's find the inverse. Now for this particular part, you're going to need me to kind of walk you through. This isn't necessarily something you've done before. So to find an inverse, it's basically a switch of the x and y. So let's just write that down. That's the key here. Switch x and y. Okay, that's the key step. So we're going to start out with our function, f of x equals 9/5 times x plus 32. We have to switch the x and y. Of course, there is no y yet. Let's change this to be a y. So now we're using y equals notation instead of f of x notation. I'm not sure why I put the x in parentheses. I guess it's because I have a 25 in parentheses up there. Not needed. Next, we're going to switch the x and y here. So I'm simply going to write it. I'll write it in red. The x is where the y is, and the y is where the x is. So you're going to write it like this. And now we just need to get the y by itself. So there's multiple ways I can go about it. I think in this particular case, I'm just going to subtract 32 from both sides. And to get the y by itself, I'm going to multiply by the reciprocal of this fraction. So I'm going to multiply both sides by 5/9. And that's going to work out to look like this. I'm going to write y equals, I'm going to bring that over to the other side, y equals 5/9 times the quantity, the whole quantity, I should put that in parentheses here, x minus 32. Okay. Now we have to have particular notation. I can't give it the same name, right? I can't call it f of x again. That would be confusing. But if you remember back up here, we had notation for the inverse of f. It's f with a superscript of a -1. So let's use that here. So I'm going to go f inverse of x equals 5/9. I'll make that 9 a little clearer. 5/9 of x minus 32. So now we've got another formula. If I were given a Fahrenheit temperature, I could figure out the Celsius. All right. Move some stuff over a little bit there. We got offline. Great. So like if I had the 77 degrees, I could sub that in here, subtract 32, right? That would give me 45, right? Multiply 5/9 times 45, and you'd get back to 25. So that's its inverse. Finally, the graph. Well, let's work on the graph of this function. And the way I'm going to do it is just switch the x and y of those points. So let's come back to this function, and let's name this one f of x. And to make the graph of the inverse of f of x, you're just going to switch the x and y of each of those points. So to find the inverse, I'm just going to take this point, 0, 32, and make it 32, 0. And then for this red point, 100, 212, I'm going to make it 212, 100. Then I connect those 2 points. Now, that I'm going to label the inverse of f of x. All right, so that's our notation. All right, and now I'd like you to finish up this activity by looking at parts D and E. Read those to yourself, answer them, and when you're ready, Play the recording for the answer. Okay, so hopefully you took time to work those out. It says they intersect at one point. What point? Well, let's look back at that graph and see where they intersect. And right here, it looks like around -40 in the x. That's the same as -40 in the y on both graphs. So, meaning what? Well, if you said to someone in France, it's -40 out, and you said to someone in New York, it's -40 out, we should feel the same temperature. Let's look at our thermometers here and see if that's in fact the case. Well, this one doesn't get down that far, but this one does. And lo and behold, -40 lines right up with -40. So it's the same temperature in both instances. All right. So finally, part E, which one would be considered f of x and which would be the inverse? Hopefully you've thought about that question. If not, pause, play the recording, work it out. Okay, so for this one, Celsius is the input, Fahrenheit's the output. Over on this one, Fahrenheit's the left side variables, we'll call it the input, Celsius is the output. Okay, and if you remember, our original function, f of x, had Celsius as the input. So that would be the one on the left, because Celsius the input, Fahrenheit's the output. Thanks for watching.